Assalamu alaikum everyone. We are starting with Poisson distribution questions, and the focus is on past papers questions related to everything in Poisson distribution. Now let's start with the basics. So this is topic 1, and first of all let's focus on the basics. So now, in order to understand the basics, let me just write down few details. We know that X follows a Poisson distribution with lambda. Lambda is the mean number of occurrences, mean number of occurrences in a specified time or space interval. So in a specified time or space interval. The formula for Poisson is with X probability X is equals to X, that is e raised to power of negative lambda, lambda raised to power of X divided by X factorial, and where X takes the value 0, 1, 2, 3, all the way till infinity. It's a discrete probability distribution, just like binomial, just like geometric. We know that expectation of X is lambda, so is the variance of X. There are two things that you have learned in Poisson. The first one is Poisson approximation to binomial. That means the data is that of binomial, and you want to convert this binomial to Poisson. There is no continuity correction because both distribution are discrete. And also there are certain conditions that needs to be fulfilled. If NP is lesser than 5 and N is greater than or equal to 50, if these two conditions are met, then X follows a Poisson distribution with NP. Because we know that in binomial, X follows a binomial distribution N comma P. Expectation of X is the mean, that is NP. So basically you take the NP from here, put it over here, provided these two conditions are fulfilled. And let me also write the other thing so that we are all aware of exactly what we are going to do. Normal approx to a Poisson distribution. That means the data is that of Poisson, which is a discrete probability distribution. We want to convert it into normal, which is a continuous probability distribution. And yes, there is continuity correction because you're going from discrete to continuous. We know that X follows a normal distribution, mu comma sigma square. When we know that expectation of X is lambda, so is the variance of X. What is the condition? If lambda is greater than 15, then X follows a normal distribution, lambda comma lambda. Because the mean is lambda, the variance is lambda, and that is how the conversion takes place. So that is basically the whole chapter. Let's start with the questions. Now the first question. Let me get the highlighter ready. It says at a certain airfield, planes land at random times at a constant average rate of 1 every 10 minutes. First part, find the probability exactly 5 planes land in a period of 1 hour. Now, if I talk about this first part, so now in the first part, lambda will change because one plane in 10 minutes. So 10 minutes, this is one plane. Therefore, 1 hour, which is 60 minutes, there should be 6 planes. That is the first thing. X follows a Poisson distribution with 6. That's the first thing. And exactly 5. Probability X is equals to 5, e raised to power of minus lambda. The value of lambda is 6. 6 raised to power of 5, that is this 5 over here, divided by 5 factorial, and then you will get the answer. Now, I won't waste time in doing the calculation. I'll simply look at the marking scheme and copy the answer over here. Because using a calculator is a trivial thing. The main thing is understanding. So over here, the first thing is this thing, 0.161. So this is 0.161, the very final answer given correct to three significant figures. That means the standard rule is work in 4SF so that the final answer is in 3SF. That is the general rule. Okay, so first part is done. Let me focus on the second part. Now, on the second part, it's saying find the probability that at least two planes will land in a period of 16 minutes. So at least two planes. So second part, and now they are talking about 16 minutes. So 10 minutes, one plane. Therefore, 16 minutes, lambda plane. So this is basically cross multiplication, lambda into 10, 1 into 16, lambda comes out to be 1.6. X follows a Poisson distribution with 1.6. And what are we interested in? At least two planes. So probability X is greater than or equal to 2, which is not possible to calculate because X takes the value 0, 1, 2, 3, all the way till infinity. So if I need this probability, that is 1 minus probability X is less than or equal to 1, which is 1 minus e raised to power of minus lambda. And this is lambda power 0 over 0 factorial, lambda power 1 over 1 factorial. This is the shortcut formula. And you use this working, and then you get this answer, which is 0.475. So 0.475, that is the answer given to three significant figures. I think that's pretty basic. Now, let me just copy this thing. No, not this thing over here. And let me paste it on the next page so that we can try out the third part, which is very interesting. Now, the third part is this thing. It says, given that 5 planes landed in an hour, 5 planes will land in a period of 1 hour. There is a connection with the first part. Calculate the conditional probability that one plane landed in the first half hour and 4 in the second half hour. Now, first of all, let me calculate all the different fragments of this particular thing. So part 3, it says 5 planes landed in 1 hour. This is answer of part 1. So that is the answer of part 1. That is this thing. And let me just copy this thing for a second. So let me just copy this thing from here so that everything is intact. So this thing is copied. Lambda is 6 and everything. So this thing is right over here. Now this thing is done. One plane landed in the first half an hour. So now 10 minutes. That is one plane. Therefore, 30 minutes, half an hour, that would be 3 plane. That is basic thing. So X follows a Poisson distribution with 3. There are 2 calculations that needs to be done. One plane landed in the first half an hour, and then 4 in the second half hour. So let's do it separately. So probability X is equals to 1 e raised to power of minus lambda, lambda raised to power of 1 divided by 1 factorial. And similarly, I need to calculate probability X is equals to 4 e raised to power of minus lambda. And then it's lambda raised to power of 4 over 4 factorial. So let me look at the answers for this. They have written it without the working. So let me just follow the same process and let me write it as it is. Now comes the conditional probability formula, which is probability of A slash B, which means probability of A occurring given B has already occurred. B is the condition. So in other words, B is the condition. The formula is probability of A intersection B divided by probability of B. And if it's independent, then probability of A intersection B, that is probability of A into probability of B. This is the knowledge that we are using from S1. Probability A slash B, probability of A intersection B divided by probability of B. If independent, probability of A intersection B is the product of the individual probabilities. Now over here, the condition is probability 5 planes landed in 1 hour. And then probability of A is 1 in 30 minutes. Probability of B, 4 in 30 minutes. Got the idea? This is 1 in 30 minutes. This is 4 in 30 minutes. Basically, these two will be multiplied, divided by probability of 5 planes. So now the working is, let me write it over here. The denominator, that is e raised to power of -6, 6 raised to power of 5 divided by 5 factorial. And this part A in red color, that is this thing. E raised to power of -3, 3 raised to power of 1 divided by 1 factorial. So I just need to write it a bit up. E raised to power of -3, 3 raised to power of 1 divided by 1 factorial. This is this one. And then the blue one, e raised to power of -3, 3 raised to power of 4 over 4 factorial. So we multiply these two and divide by this. That is the exact working. This is probability x is equals to 1 in half an hour. This is probability x is equals to 4 in the next half hour. This is probability x is equals to 5 in 1 hour. So this is 30 minutes. This is 30 minutes. This is the and thing. And probability of A slash B, that is probability of A intersection B divided by probability of B. This A intersection B, because it's independent, it is a product of these two. And that is how you get this answer, which is 0.156. Correct to 3 significant figures. So yes, this last part was a star question because the concept of conditional probability is asked. Now, in the WhatsApp group, let me write the plain question. So this is plain question. Conditional probability, conditional thing. So is it all good, all clear? This is which question? This is question 2. Okay, just acknowledge it on the WhatsApp. So I can move on to the next one. Now, this is question number 5. Another question. Okay, let's move on. So question number 5, it says, in their football matches, let me start underlining. In their football matches, there are 2 teams. They are talking about the first one, rover score goals independently and at random times. The average rate of scoring is 2.3 goals per match. State the expected number of goals that rovers will score in the first half of a match. Okay, now the very first thing, that is expected number. We know that expectation of X is lambda, so they're asking for lambda. So therefore, in one match, the team is scoring 2.3 goals. So in half a match, they will be scoring 1.35 goals. So that is the value of lambda. That is the first thing. Second part. Now it says, find the probability that Rovers will not score any goal in the first half of a match, but will score one or more goals in the second half of the match. Now, this is something similar to this part. It's not conditional probability, but it's this thing about that and thing. So now, first of all, let me write it down. Second part. That is X follows a Poisson distribution 1.35. This is half match, whether it's the first half or the second half. So no score in the first half. So probability X is equals to 0. That is e raised to power of negative 1.35. And one or more goals scored. That means at least one, which is 1 minus probability X is equals to 0, which is 1 minus e raised to power of negative 1.35. So therefore, it's the concept of and. So this is e raised to power of negative 1.35 multiplying with 1 minus e raised to power of negative 1.35. Let's double check the answer. The first one, it's not 1.35, it's 2.3 divided by 2, 1.15. My bad, a small mistake over here. So this is 1.15 and it's 1.15 over here. And then 1.5, and then 1.5, and then 1.5, and then 1.5. So small arithmetic mistake. So 1.15, 1.15, 1.15, 1.15, 1.15. Okay. So this thing is done, the first thing. And then probability X is equals to 0 is this thing. And then probability X is greater than 0. That is greater than or equal to 1. That's the same thing as greater than 0. That is this thing. So we multiply these two together, and this is the answer that we get, which is 0.216. 0.216 correct to 3 significant figures. That is the second part that's done. Now let's move on. Football matches last for 90 minutes. In a particular match, Rovers score one goal in the first 30 minutes. Find the probability they will score at least one further goal in the remaining 60 minutes. So we are interested in scoring one further goal. Okay. So now 90 minutes, there is 2.3 goals. So this is basically ratio proportion. So part 3, there is a 30-minute, 30-minute, and 30-minute. There are 3 parts of 30 minutes. So now if we are talking about 2.3, this should be 2.30 divided by 3, 2.30 divided by 3, 2.30 divided by 3. Got the idea? Because this is the total number of goals scored in a match, 2.30. And this is 1 part, 2 part, 3 part, that adds up to 90 minutes. Now, for the last 60 minutes. So this is 2/3 of 2.30. This is 1/3. This is 1/3. That's 2/3. 2/3 of 2.30, that is 60 over 90, is 2/3 of 2.3. That is 1.533. This is 1.533. That is the lambda that was to be used in part 3. And it says one further goal. My bad. Let me just, we are not interested in the first, whatever happened, happened. We are interested in the last 60 minutes. Probability X is, it says at least one further goal. So X is greater than or equal to 1. That is 1 minus probability X is equals to 0. This is 1 minus e raised to power of negative 1.533, 1.533 raised to power of 0 over 0 factorial. And this is 1 minus e raised to power of negative 1.533. And this answer comes out to be 0.784. Correct to three significant figures. This thing is done. Now, this is this part, which is the third one. Now, they're talking about another team, and I need more space. So let me add a page over here. Now it says independently of the goals scored by number of goals scored by Rovers, the number of goals scored per football match by United has a Poisson distribution with mean 1.8. So Rovers, that is 2.3 goals per match. And United, that is 1.8 goals per match. Now it's asking, find the probability a total, that's linear combination, of at least 3 goals will be scored in a particular match when Rovers play United. So part 4, total is about Rovers plus United. Total follows a Poisson distribution. It's about the full match. That is 2.3 plus 1.8. So total follows a Poisson distribution with 4.1. This is linear combination of Poisson variable. You simply add the two means. So now what's happening? At least 3 goal. Probability x is greater than or equal to 3, which is 1 minus probability x is less than or equal to 2, which is 1 minus e raised to power of negative 4.1. This is 1 plus lambda square over 2 factorial. You calculate this probability and you get this answer. Just a reminder, if some people have forgotten this thing. So what exactly am I writing over here? When we talk about a range of values for calculation for lesser than or equal to, this is what happens. E raised to power of minus lambda, lambda power 0 over 0 factorial, lambda power 1 over 1 factorial, lambda power 2 over 2 factorial, lambda power 3 over 3 factorial, and so on. So basically, this first one, lambda power 0 over 0 factorial, it becomes 1. And this next one over here, lambda power 1 over 1 factorial, simply becomes lambda. So basically, this is lambda that I've written over here. And this is 1 that is I've written over here. So that is what the formula is all about. So now the Rovers and this question is also done. Now let me pause the recording for a second, and I would like you people to try this particular question out. So let me pause the recording. So now let's look at this question. It says the number of lions seen per day. So this is number of lions seen per day during a standard safari has a Poisson distribution with 0.8. The number of lions seen per day during an off-road safari. So that's a different one. So the number of lions seen per day during an off-road safari has a Poisson distribution with 2.7. The two distributions are independent. Now the first part, it says Susan goes on a standard safari for 1 day. So that means the value of lambda is 0.8. Find the probability she sees at least 2 lions. So now I'll just write down the step. So first thing first, that is part 1. So we will say a standard S safari follows a Poisson distribution with 0.8 and at least 2. So probability x is greater than or equal to 2. That is 1 minus probability x is less than or equal to 1, which is 1 minus e raised to power of negative 0.8, 1 plus 0.8, and that is the answer. That's the first one. The second part. Now it says Dina goes on a standard safari. So this is also standard safari for 3 days. And then on an off-road safari for 2 days. Find the probability she sees a total of fewer than 5 lions. So now if we are talking about total, so the total is standard safari plus off-road safari. So that is 0.8 plus 2.7. That is 0.8 plus 2.7. That comes out to be 3.5. This is for per day. But there is an issue. The number of days are different. So before I proceed, before I do the total, let me just deal with them individually. Standard safari 0.8, that's 3 days. So standard 3 into 0.8, that's 2.4. Off-road safari, that is for 2 days, that is 2.7 into 2. So this is 2.7 into 2. So that comes out to be 5.4. Now the total is 2.4 plus 5.4, which is 7.8. So total follows a Poisson distribution with 7.8. And what are they asking us? Fewer than 5. So probability T is less than 5. Probability T is lesser than or equal to 4. This is e raised to power of negative 7.8, 1 plus lambda square over 2 factorial. This is lambda cube over 3 factorial. This is lambda power 4 over 4 factorial. And then you get this answer. So let's double check the working. That's the first one. And this is the second one. This is all good, all clear. Now, the third one that I need to focus on because that involves logarithms. So let me write it over here. And let's look at the third one. Now, the third one is this thing. It says Khalid goes on a standard safari for n days. Now, keep in mind, standard safari is this one. That is 0.8 per day. Now it says where n is an integer. He wants to ensure that his chance of not seeing any lions is less than 10%. What's the use of going to a safari when you're not interested in seeing a lion? Maybe he wants to ensure that his chance of not seeing is less than 10%. Find the smallest possible value of n. Now, first of all, for 1 day, lambda equals to 0.8. For n days, lambda will be 0.8n. Okay. So now we will say x follows a Poisson distribution 0.8n. And it says not seeing any lines. Probability x is equals to 0. That is e raised to power of negative 0.8n. That is less than 10%. E raised to power of negative 0.8n is less than 10%. Take natural log ln of both sides. So ln e raised to power of negative 0.8n. Can someone take out a calculator so that we can solve it live? This is 0.10. Negative 0.8 raised n, it comes down, ln e is lesser than ln of 0.10. Negative 0.8n is lesser than some negative value. So therefore, n is greater than this negative value divided by negative 0.8. So this is ln of 0.10. So let me also take out my calculator. And this is scientific calculator. This is 0.1. I'm pressing the ln. This comes out to be negative 2.3025. 2.3025 divided by 0.8. That comes out to be n is greater than 2.878. Pick the next integer. It's not about rounding off. It's just picking the next integer. So n comes out to be 3. So n comes out to be 3. And that is how this question is done. All good, all clear? Okay. Why don't you go ahead and try out this particular question? Let me pause the recording. So now let's look at this question. It says 2 independent random variables x and y have the distribution Poisson with a variable of 2, with a parameter of 2, and another Poisson with a parameter of 3. So let me first write it down. X follows a Poisson distribution with 2, Y follows a Poisson distribution with 3. The first part, it says, given that x plus y is equals to 5, find the probability x is 1, y is 4. What is this thing? This first part is about conditional probability, just like the plain question. And coincidentally, the values are exactly the same. Probability x plus y equals to 5. So first of all, over here, x plus y follows a Poisson distribution. And this thing is 2 plus 3. This is also 5. And probability x plus y equals to 5. That is e raised to power of negative 5, 5 raised to power of 5 over 5 factorial. This 5 over here, the lambda, that is this 5. That is this 5. And this 5 over here, this one, and this one, and this one, that is the one that's used in calculation. Just like the planes question, 5 planes landed in 1 hour. Now, they are asking x is equals to 1. So x follows a Poisson distribution with 2. Probability x is equals to 1. That is e raised to power of negative 2, 2 raised to power of 1 over 1 factorial. Similarly, y follows a Poisson distribution with 3, and y is equals to 4. So probability y is equals to 4, e raised to power of negative 3, 3 raised to power of 4 over 4 factorial. Now, probability a slash b, that is probability of a intersection b divided by probability of b. It says independent over here, just like it said in the first question. That is, at a certain airfield, planes land at random time and a constant average rate of 1 every 10 minutes. And it's part of Poisson distribution, that the number of occurrences are independent of one another. That is why we were able to multiply this out. So now, applying the same principle over here, that is this particular question, since it's independent, so therefore for independence, probability of A intersection B, that's probability of A into probability of B. So let's say this is probability of A. Let's say this is probability of B. And this thing over here is the condition for 5. So therefore, I'll write e raised to power of negative 2, 2 raised to power of 1 over 1 factorial, multiplying with e raised to power of negative 3, 3 raised to power of 4 over 4 factorial, divided by this thing, the red one, e raised to power of negative 5, 5 raised to power of 5 over 5 factorial. Let's double check the working. That is over here. This thing, that is the first thing. This is the red one. This is probability x plus y equals to 5. This is the other one. Let me call it the blue one. So that's this blue one. And this is 2 raised to power of 1 over 1 factorial. And let me denote it by the green color. That is over here like this. This is the green one. And that is how we will get this particular answer. And this comes out to be 0.259. So therefore, this answer is 0.259, correct to 3 significant figures. That thing is done. Now let's try out the second part, which is slightly different. So let me try this out. Let me add another page to it. Now it says, given that probability x is equals to r, we are talking about x. So let me write this thing. First of all, this color, we are interested in x. X follows a Poisson distribution with 2. Probability x is equals to r. That is e raised to power of negative 2, 2 raised to power of r over r factorial. So I calculated this separately. Probability x is equals to 0, that is e raised to power of minus 2, 2 raised to power of 0 over 0 factorial, which simplifies to e raised to power of negative 2. Now it's saying probability x is equals to r is 2/3 of probability x is equals to 0. So this is e raised to power of negative 2, 2 raised to power of r over r factorial is 2/3 of e raised to power of negative 2. We just have to simplify it. Very simple. So e raised to power of negative 2 cancels out with e raised to power of negative 2. We are left with 2 raised to power of r is 2/3 r factorial, and they are asking to write it like this. Is there any other term that is missing? So 2 raised to power of r minus 1, they're just using indices. So 2 raised to power of r, 2 raised to power of 1 is r factorial over 3. Okay. This 3 is also going there. So 2 raised to power of r minus 1 into 3 is r factorial. Is that the answer? R factorial is this thing. And verify, that means plug in and check. Verify means plug in and check. R is equals to 4 satisfies this equation. Plug r is equals to 4 on both sides. 3, 2 raised to power of 4 minus 1. That is 4 factorial. We know that 4 factorial is 24, 3 as it is. This is 2 raised to power of 3. 8 into 3 is 24. Yes, it's verified. So that completes this part. That is the basics. And the questions were from the topical book. And this was all about exercise A, some nice questions that we solved it out. So let's finish the lecture over here.